All right, welcome. Hopefully the video won't flip today. This is Unit 2, Day 2. This is page 7 of your note packet. We're going to start looking at the goals are to determine whether a function is even, odd, and technically if it's neither. Okay, so we're going to talk about parent graphs again, like x squared and the common functions, and kind of look at them to see if they are even, odd, or neither. All right, so a function, so this is by definition, an even function. So function is even when you plug in a negative x into the function, and then you see what you end up with afterwards. And you can compare it. So if you plug in a negative x, so something like x squared, if you plug in a negative x and you see what you end up with, and you compare the beginning to the end, what you start with to what you end with, and you compare those two. If it's an even function, if it's an even function, what you start with and what you end with will be exactly the same. So all positive and negative signs stay the same. Okay. Another way to look at it, so that's like also looking at exponents. Another way to be with a graph is symmetric with respect to the y-axis. So we'll look at exponents, we'll look at if you plug it in, and we'll look at the graphs. An odd function, by definition, if it's odd, is if you plug it in, same thing, so the negative x, so you just change like the sign of all the x's to be a negative, and what's going to happen is the signs of every, and I mean every term, is opposite. So if it's odd, it's going to be symmetric with respect to the origin. So something like, hopefully makes sense, a cubic function. Cubic function goes like this and goes like this. Now, a cube is an odd number, and it's an odd function, and it is symmetric with respect to the origin, meaning an odd function will be in the first and third quadrants. So it's going to be symmetric in those. Or the second and fourth quadrant. So it's going to go diagonally. Now, if you're looking to figure out is a function even, odd, or neither, and I give you the equation, really what you do is you say, look at all the exponents. Are all the exponents even? So if you have all even exponents, then it's an even function. Algebraically, we'd plug in negative x. So everywhere there's an x, I plug in a negative with the x. And then I start to think, okay, a negative to an even power, so a negative times a negative times a negative times a negative for the fourth power means it's going to end up being, all the negatives will cancel out, so we'll start with that, or I'll end up with that. And minus 3 again, and then a negative x squared again is going to be x squared. So what I end with and what I started with, these are the same. That also means it's even. A quicker way to determine is really looking at the exponents, but you can plug it in and do it the other way algebraically. Now, an odd function, just like the even, if you look at all the exponents, they got a 3, and this is technically a 1 with the 9x. So if these are all odd numbers, then it's an odd function. Okay, algebraically, plug in negative x. So I have 6 negative x to the third plus 9 times negative x. Negative x to the third would leave me with, sorry, it's a 6. A negative x to the third plus negative 9x, because I do a negative 9 times, or sorry, 9 times negative 1. So technically this means this is a negative 1 here times that. I'm going to have a negative 6 x to the third, because a negative can hop outside here, plus negative 9x. Negative 1 to the third is a negative 1. I can actually multiply those together right away because order of operations says I'm going to do the exponents and then multiply, so I'm just multiplying them right away. Now when you look at the signs, these two are both negative. What I started with were both positive. If they are completely opposite, so everything has to be opposite, all positives change to negatives or vice versa, then this is an odd function. Okay, and now when you look at something like this, the last one, I have an even here, I have an 1 here, so this means it's odd. If it's a mix of even numbers and odd numbers, you're not going to have an either or. It's not going to be even or odd, it's going to be neither. So down here, abbreviated, if a function has only even exponents on the x, including x to the 0 as a constant, so even constants like 6 or negative 2 or whatever is at the end, it will always be even. It only has odd exponents on the x's, the function will be odd. And if it's a mix of even and odd, then it's going to be neither. And that's when it's even and odd, you weren't talking about the exponents. Okay, over on page 8. So we have some graphs to look at. Whoops, Daisy. Alright, so you're determining if it's even, not off, odd, or neither. Okay, so make these graphs real quick. These are the parent graphs. So f of x equals c. So this means a constant. So it's like saying f of x equals 3. Graph f of x equals this. This is like y equals x plus 0. Y equals mx plus b. Okay, absolute value, cube, square root, x squared, and x to the third. So graph those. So pause the video or go to the, I'm going to stop the video and start on the next video with these graphs. So this is a good stop point to actually make the graphs.